Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be looking at more on data privacy, and we're going to be focusing on looking for unique combinations, and also we're going to do something on generalization. So let's go ahead and see what we can learn. All right, so we're going to go ahead and set up our data here, and we've been focusing on data privacy lately. That's been the theme of the past few videos. And what we're going to do here is we're going to examine how to deal with unique combinations. And this will make more sense when you see it, but sometimes by combining the data from two different columns or more than two columns, you can find unique combinations that will allow you to identify that particular individual. And we're going to show how you can find ways to get around that per se. So first we're going to load our packages here, our library, excuse me. I don't think I need NumPy. We're going to try it without NumPy. And then we're going to import our data. We're going to use something from the Pi dataset library. That's this guy right here. And we're going to use a dataset called SLID, S-L-I-D. And we're going to take a quick peek at what it looks like. So here's the SLID. We're going to save it as an object called DF. And excuse me, we are going to have these 5 columns: wages, education, age, sex, and language. That's what we're going to be looking at as we go through these videos. Now with the unique combinations, this will make more sense when you see it. Let me show you what the potential problem could be. And so what we're going to do is we're going to look at education, these numerical values here, and language. And so we're going to go ahead and take a look at this. And so what's happening is that I created this object called DF original. And what I did was I grouped it by education and language. The size is what I used to print this right here. And then to make the count column, I used the dot reset index method. So that's what I'm using these two methods for right here. And so when we print this, you can see that for people who have an education level of 0, there are 4 and education of 0 and whose language is English, the count is 14. But look down here in row number 5. There is one person, that's the count right there, who has an education level of 1 and a language of other. In other words, this person can be identified clearly. Whereas within row 0, there's 14 people, so the odds of picking a particular person is 1 in 14. The odds here of finding out who this person is in our data set is 100%. As soon as I subset my data for an education of 1.0 and a language of other, I will know who this person is. So we want to find ways to try to address that, as that could be a major problem. Now, one other thing we're going to do here is we're going to show you groups that have 4 or less than 4. And I'm going to show you how many times this can be a problem. And so you can see right here, as I run this data right here, that we have many columns or many combinations where there are 3 or less people in a particular group when you combine them based on the numerical variable of education and the categorical variable of language. So these are all of them right here. Let's see how many there are. Oh my, over about 274, over 270. So what we're going to do now is we're going to find a way to reduce these combinations by using some basic coding. So here we go. And in case you don't know what I did up here, I took my new data set called df_original, and I subsetted it with a count of less than 4. Now let's move on and let me show you how you can address this particular problem. So here we go. So what we're going to do is I'm going to show you how we can simplify this. Very, very simple. It's not going to take a lot of work. I'm just going to copy and paste the code over here so you can see it. So we're going to put this right here. And what's going on here? Well, in this first row right here, this first line, I'm creating a new variable called education group. And what I'm doing is I'm cutting the data because it's continuous data by using the dot cut method here, or function. I'm using this from the pandas library, and I'm cutting the variable education into 10 equal groups of bins. So it's, like bins on a histogram. I'm dividing it. The number of bins depends. If you have more bins, you're more likely to have a unique combination. Whereas if you have fewer bins, you're less likely to have a unique combination. Then you've already seen this right here. I've run this code before, but what's different is that instead of the education variable, which was the original one, I'm now using the variable education group. And so I'm just counting to see how many are in a group when I group them by education underscore group and language. So I'm still doing the group by again, but this time with my modified variable of education underscore group, which was divided into 10 equal parts. And so then I just show you after that. Let's take a look. And so now you can see in group 0, there's now 25. It used to be 14. But what's happening is this. You can see here that education group goes from, this first row right here goes from negative 0.02 to 2.0. So that's the first cut that the data made. So basically from 0 to 2.0, that's kind of what that is. And of course, you're going to have 3 different groups that fall under that. That's going to be English, French, and also other, because those are our 3 categories in our categorical variable. So English, there are 25 people with a score between 0 and 2 and whose language is English. There are 6 people who have an education group score between 0 and 2. And there are 28 people whose language is other who have a score between 0 and 2. And then et cetera, like that. Now, instead of 273 or 274 rows, we now have 29 rows. So it's much more reduced. Now we're going to do that same piece of code we did last time when we were trying to figure out how many groups have less than 4. And you can see that, there's not too many of those. And now it's 0. And of course, you can change this number right here. I can say like less than 5, still 0. Why don't we go up to 6? See what we got here. And so now we have one group with less than 6. And so, but there's still 5 people here. So it'd be much harder to identify individual people when you cut the data like was shown in this example. Now we're going to kind of switch gears here and talk about generalizing data, which is not quite as complicated in terms of what you're trying to do. And so I'm going to copy and paste this, and we're going to wrap this up. So here's what's going on here. The first thing we're doing here is we're rewriting the data set that we made so that it'll run properly. So we're going to, this data these 2 lines right here, they were ran when we were preparing the data way back at the beginning of the video. So it's the same code. And so I'm just rewriting it to start fresh. And right here in line number 3, I'm making a dictionary called hierarchies. So we have a key of European, values of French and English, key of other, and a value of other. So nothing really changing there. Then I'm making an empty dictionary right here, I believe. Yeah, empty dictionary right here called language hierarchy. And then what we're doing here is that we're going to run a for loop, if you will, with the key and underscore language values as our value here. And we're going to do it on hierarchy. So this guy right here, these items right here, that's what we're using. And then, for language and language values, that's what we're going to use. And we're going to use the key. So what's going to happen here is that it's going to go through our data, and it's going to, every time it sees French or English, it's going to replace it with European. And every time it sees other, it's going to leave it as other. That's basically what's going to happen. So this is our hierarchy right here. And then we're going to apply the education underscore, the language generalization hierarchy to languages. That's a typo right there. To languages, sorry. That's what we're going to do. We're going to use language hierarchy. It's a language hierarchy. Sorry about that. And then we're going to wrap this up. So we create a new variable called language generalized, and we're going to we're going to use language, and we're going to map this language hierarchy. So this is the hierarchy right here, this for loop. And then when we run this, we're going to just take a peek at the first 30 rows or so. Run it. All right. So here's what we have. Notice we still have our column called language, but now we have a new one called language generalized. So now if you're an English speaker, well, that's a European language, etc. And then all the ones that are other are going to be still classified as other. You can see French right here in row 16. is classified as European as well. And so this is another way to protect people's identity by removing the choice between English and French. You make it harder to determine who individual people are within your data set. That's the point. And so by running this for loop right here, we are able to achieve that. They call this a hierarchy. This is language again, it's typo. And then language. So that's what we did here. We created the hierarchy right here in this line. And then down here, we ran our for loop, key underscore language value and hierarchies. So this is kind of like our filter variable right here. And the items are coming from up here in the hierarchy. And then for language and language underscore values, so the language is inside this, we are overriding them with the key value. So this is the key value. And so wherever you see French or English is going to be overwritten with this key value. Wherever you see other, it's going to be overwritten with other. And so then we apply it right here as shown. And that's essentially it. So let's go back and review this, make sure it's clear, and conclude the video. So in this video, what we did is we looked at how to deal with unique combinations and how to generalize data when necessary. And so we started by first grouping by our continuous variable here and also by our categorical variable here. And we had all these combinations. And when there are fewer people in a particular combination or within that group, it is easier to determine the identity of that particular person. So what we did is we cut that continuous variable into 10 equal parts, which helped to reduce the number of potential unique combinations. And by doing that, when we ran it again, we went from having over 270 groups to having almost 30 groups. And we had no groups that had less than 4 people in them, as you remember. And then in the second part, we looked at how to generalize data. And what we did was we basically replaced any line where you see the word French or English, we replaced it with European to say what kind of language it is. And wherever you see other, we just kept it as other. We then created this hierarchy right here, this for loop, if you will, where it takes the key value right here in language values. That's the place filler variable, if you will, using in hierarchies.item, this stuff up here. That's what we're looking at. And then we ran this and we were able to complete that. And then we mapped it to the language hierarchy. That's what we did. So I want to thank you so much for watching this video. My name is Darren Thomas. I am the Director of Educational Research Techniques. You take care and have a nice day.